Okay, so let's get into lesson 12, Oracle database in memory in RAC. Oracle database in memory option is not new feature. It was available in 12.1. And also we could configure in memory option in RAC environment. The purpose of this lesson in this course is to give you a little bit of a background and also to give you some enhancement in 12.2. Objectives. And this lesson will introduce some of the background of an in-memory option and also goals and benefits and architecture of the in-memory column store. So in-memory option leverages one of the components of SGA, which is called the in-memory column store. And also how to implement in-memory column store in a database. And also a new feature available in 12.2. In-memory column store is just a small memory component. Actually, I better say part of a SGA memory component. And it was available in 12.1 patch set 1. And we could store the data in this memory in the columnar format. So if you are managing Oracle database and you can bring mixed workload in the Oracle RDBMS, one for transactional operations, and the other the workload for maybe analytic queries. So in-memory column store, it was designed to support analytic queries by storing frequently accessed data in the columnar format. Now, before we get into in-memory column store a little more, let's take a look at class note. Okay, so I have this summary, and this example in the class note is an example of an Oracle Big Data solution. But it could be OLTP environment and 2 Oracle data warehousing or BI system. Okay, it could be different. But I made one simple example. This is one of the examples. This example is an Oracle Big Data solution. And these days we can gather information from many different sources, maybe in a mobile device or from the web, and also SNS. So you can get a lot of unstructured data from different sources. So in order to manage it and the high volume of data that is unstructured data, and in Oracle environment, we can leverage Oracle Big Data Appliance because there is a way to store unstructured data in Oracle, the Big Data storage. So we have Oracle NoSQL database solution, and also we have a Hadoop solution in the one engineer system. And also, we can process this data in the Big Data Appliance. And also, some meaningful information can be pulled out from the Big Data Store to Oracle RDBMS, for example, Oracle Exadata. And also, you manage those data in the database, in the Exadata environment, for example, for data warehousing purpose. And also, you can run reporting queries to get information what you need. And also, for decision support, and also to ask your business questions by analyzing the data in the data warehousing environment, we also can use in a BI system as well. So Oracle's engineer system for BI is Oracle Analytics. So we could collect a large amount of data from different sources and save it in the Big Data Store, and then we will process data, and process the data is copied over to Oracle RDBMS environment like Exadata, and then we can also copy this information to BI system for further analysis. That's what we could do. Okay. Now, where's an in-memory option is located here. Actually, in-memory option is here. Okay, you are in the Oracle RDBMS. I want to bring some of a BI function into RDBMS. So I want to perform certain analytic operations and activities in Oracle RDBMS directly without having to copying the data to the another system. So that's also possible. So in memory, the option that support in database analytics. And also a little bit more background here. In the data warehousing environment, we typically organize the data in the star schema. And you have many of lookup tables, and that describes data captured or your business measurement. For example, products table, that's a lookup table, and dimension table, and also times table, customers table, channels table. And these tables are relatively static and relatively small. And your business fact and business measurement is stored in the fact table, like a sales table. So this sales table refreshed as a part of ETL pretty much every few hours and daily basis. And then in the data warehousing environment, like in a data warehouse in Exadata, for example, and you can run reporting query. Okay, so I want to make sales report, okay, for certain products, or I want to actually make a sales report for certain product based on a certain time period. And also, I want to say which product sold through internet channel. So your business measurement in the fact table can be analyzed by joining with the lookup tables. Now, in order to speed up your reporting query, in RDBMS, we could use a dimension object, meaning that among these dimension tables, we could define relationship. And also, we can define levels and hierarchies and so on. By doing so, if you have a materialized view on these tables, then we can take advantage of a metadata predefined. So when you run your SQL statement, it's possible to rewrite your SQL statement behind the scene to take advantage of a materialized view. So that was a possible option. So materialized view stores pre-computed the data and pre-joined the data, so we can get a little bit of benefit. And also, we can take advantage of analytic functions as well in the RDBMS. So you have a business fact, and you can make a reporting query, and we can also analyze reported data based on your business requirement, also for future plan. Okay, so this was actually a data warehousing environment. Now, in RDBMS, I want to actually improve my stock query or analytic query even further. So what other options are available? So think about that. These days, many customers run their own RDBMS, actual Oracle RDBMS or database in the powerful system that provide very large physical RAM. So the concept of an in-memory option is it possible to take advantage of a large memory, and so we configure a large memory, a large component of a SGA to support the processing of analytic queries. So that was a concept behind of an in-memory option. So this is the one simple example. Think about that. I want to make sales report based on different criteria, based on time, based on product, based on channel, based on customer. Okay. When you look at the fact table, you will see the volume of the data is huge. And also, sometimes you may see 300 columns and 400 columns of a table. And you run analytic queries against those large table. But when you look at analytic code, it only requires few set of columns and also only few measurement. Even though you only need a few columns and also a few measurement, we have to read many of unnecessary columns. And think about that, you have 300 columns, but you only needed 5 columns. So every time when we read one row, we have to read over 200 columns that is not needed. That eating up large amount of memory, and also that will slow down your analytic processing. That's why many customers wanted to speed up analytic query by creating indexes, analytic indexes. But what is the downside? The problem is if you add so many indexes, and that will slow down your DML performance. So that will be another problem. So because of this reason, what we want to do now, we want to actually change the strategy slightly in the architect level. So look at this. I have a customers table, and I have a sales table with a list of IDs and columns, and we have a business measurement. And if you have analytic queries, the access to quantity sold and amount sold, very frequently, then I want to cache this portion of a business measurement and this portion of a business measurement in memory, especially in memory column store. But when we store these business measurement, we're not going to store as is. Instead, we're going to actually rotate data. So the list of quantity sold value will become one row. And also list of amount sold will become one row. So when you look for certain the data set and to get amount sold from the filtered data or quantity sold from filtered data, I only read one row and then just filter. And also I read another row and filter. So it will give you a lot faster analytic processing. So it doesn't require index. So by using in-memory column store, you can dramatically improve performance. And also, we can fully utilize large physical RAM by making a larger in-memory column store, which is a part of SGA memory space. And also, it allows us to drop many number of unused indexes or unnecessary indexes. By doing so, we can maintain good performance of a DML as well. Okay, that was in the background. So queries run a lot faster, and DMLs are faster by dropping unnecessary indexes, and AdWords queries run with a good performance as well. And in-memory column store, there are two parts of memory structures. One is 1 megabyte pool and 64 megabyte pool. And we can size in-memory column store by using in-memory underscore size. That's a component of SGA. So far, it's the same as the 12C R1. And so in order to implement in-memory column store as an administrator, you log in as admin, and you're going to set in-memory size to configure in-memory column store, and then shut down database and reopen. Whenever you want to change it, in-memory size, you had to reopen. Wait a minute, just to adjust the memory component size, do we have to restart? That was actually one challenge in 12.1. What's new in 12.2, now it's possible to change it in-memory column store dynamically without having to restarting. So that is one nice benefit in 12.2 and the enhancement in 12.2. And in-memory column store population. In order to take advantage of an in-memory column store that is configured in memory, you will have to alter table to use it. For example, I want to take advantage of an in-memory column store, especially for sales table. And also, you can use a no memory option. I will populate all columns in the columnar format except for product ID in this example. And also, at the table space level, you can also enable in-memory column store. So by doing so, all tables and objects in the table space will be populated in-memory column store in the columnar format. And we also have a population. So when does Oracle populate tables, the columns of a table in the columnar format? That's based on priority. If you alter the table to use in-memory column store with a priority critical, high, medium, and low, then based on internal schedule, periodically objects are populated in in-memory column store format. But you enable the in-memory column store at the object level, but priority is none, for example. Then that's on-demand based. Only when user requests object, the time when the object is accessed, the data is populated in in-memory column store. So that's a priority-based population. And the other one is in-memory column store in RAC. Is it possible to use in-memory column store feature in RAC environment? Absolutely. Okay, the columnar data is spread across instances, across in-memory column stores. Okay, and we have options, so a few distribution options here. So we have alter table name in memory, distribute by partition. So we can actually convert data into columnar format at the partition level and then spread. So one partition of a data stored in instance 1, another partition of a data in the second instance, another partition of a data in the third instance, and so on. Or even at the service level as well. Okay? But here's the one thing. My analytic query requires full table scan, for example, but my data spread across. So how can I take advantage of the data spread across instances? Now, if you want to take advantage of an in-memory column store in RAC environment, you will have to start the parallel execution servers based on, at least based on number of instances, to spread parallel execution servers across instances. And also enable the in-memory parallelism. Because when you run parallel query, Oracle take advantage of direct path I/O by leveraging PGA. But in-memory column store is not part of a PGA. It's part of SGA. So is it possible to take advantage of a SGA memory component? Yes, that is the in-memory parallelism. So you have to enable the parallel degree policy auto. By doing so, we have option and we have the case where we can take advantage of SGA component. Okay? But there is an exception. Exception is in Exadata environment and other Oracle engineered systems. Instead of spreading data, it's possible to duplicate in-memory data across instances. So we don't have to visit every single instances to read. Instead, you just connect to one of the instances and then read the data what you need. So that is a benefit of in-memory column store in Exadata or other engineered system. So this is the highlight. By default, and you partition the table, for example, you partition the table spread across all instances. Or if this table is not partitioned, then range of a row will be selected to spread your data across in-memory column stores across instances. So in that case, you have to start parallelism to take advantage of all instances. So you have to enable the in-memory parallelism. And the other one is, if this were an Exadata environment and other engineered system, then all this data the same set of data is stored here, and same copy is here, and same copy is here. So we don't have to spread parallel execution servers across instances. That's another thing what we can see. Now we also have an in-memory fast start. That's another nice feature. Okay, so what is this feature? Think about that. You populated the frequently accessed data in the columnar format. So you have enough information, and your memory is warmed up, so your analytic queries can take advantage of it. But at some point, you have to restart instance as a part of a maintenance, or to change static parameters. There could be many reasons. If that is the case, the data stored in columnar format must be flushed out. And the next time when you restart instance, then we have to wait until memory is warmed up to take same benefit. So that is a challenge because that will require additional resource, and that will affect your analytic queries. The good news is, starting with the 12.2, we have this nice feature. Okay. I don't have actually this slide. I suppose that, okay, so I have this slide. So we have actually this feature. So what we can do is, before shutting down database instance, your columnar format of data is stored in the table space as is. So we store same output, same data in memory in the table space that is defined as in-memory fast start. So next time when you restart database instance, the data stored in the columnar format in the disk location, and this will be cached into the memory directly as is. So we don't convert raw format of a data to columnar format of a data, because before shutting down instance, the what's in the in-memory column store is written to table space location is called fast start table space area, and then when we restart, we just copy back to in-memory column store. So this will give you the better performance even when you restart database instance. So we store in-memory data in the columnar format of in-memory column store as is in the table space, which called the fast start area. So to use this feature, we use DBMS in-memory admin enable fast start, and we provide the table space name. So this table space will be defined as a fast start, and in-memory columnar format of a data is written to this location when you shut down database instance. And the fast start area is shared across all RAC nodes. Only one copy of in-memory column, the columnar format unit reside in fast start area. So if your environment is Exadata, so each instance has a duplicated copy, but it doesn't mean that we have to store multiple copies in the fast start. We only need one copy. So next time when we restart, only a single copy they will be stored in each instance. And how database read from fast start area? Fast start area defines what data is loaded when database is reopened, but when it is loaded. And data population is controlled by priority. So even when we load columnar data in the fast start area to the in-memory column store, we load the data based on in-memory object priority. Okay. Okay, so this is lesson 12.